This question has us converting our given angle, which was 210 degrees, into radians. So what we're going to do is start off by writing 210 degrees, and I need to multiply that by a ratio that would move it into a radian. So that ratio is going to be pi radians divided by 180 degrees. So when I multiply these two together, 210 degrees times pi radians will give me 210 degrees, and again, pi radians, divided by 180 degrees. And that's because I do the top part times the top, and then bottom part times the bottom part, and I'm left with 210 pi over 180. So I write that like this. Now the degrees are going to cancel out, and I'm going to be left with radians, and I need to reduce that 210 by 180. Usually I just throw that into the calculator. It's going to kick out 7 over 6, and then I make sure I keep pi radians on the top as my final answer. So just to recap, all you have to do is take your degrees, multiply by pi over 180 degrees, and then do a little bit of reducing, and then you get your final answer of 7 pi over 6. In this question, I'm going to start with my angle, which was 210 degrees, and I need to create a couple of coterminal angles. Now, what this means is, well, here, let me actually rotate this first. So I'm going to quickly rotate this angle. I'm going to have 210 degrees end up right around here. Now, what a coterminal angle is it's an angle that rotates, well, in this case, 210 degrees, so that the terminal side is right on top of it. But I want another one, so I'm going to rotate a full 360 degrees more to end up with a terminal side that is directly on top of that. So I need 210 degrees and add a full 360 degrees more, and that's going to give us our answer. So if we do that, I believe it's going to be 570 degrees. So that angle is coterminal with 210. If I want to do another one, I could just add another 360. So 570 degrees plus another 360 is going to equal 930 degrees. So 210 degrees is coterminal with 570 degrees, also coterminal with 930 degrees. Now, I could have started with 210 degrees and just subtracted 360. If we did that, that would have left me with a negative 150. Oops. So that's a negative 150. Let me rewrite that a little bit here. Okay, so then this would also be coterminal with these other three up here. In this question, we need to draw an angle of rotation. I already did this in my previous one, but I'm going to talk a little bit more about it here. So I'm going to start with a ray going in this direction. That's my standard position, and I need to rotate it 210 degrees. So if I rotate it up into this point, that's going to be 90 degrees. If I keep going, this is going to be 180 degrees. And if I keep going another 90, it keeps going up by 90 degrees. I'm left with 270. So rotate it all the way around, and my terminal side is going to end up staying somewhere between 180 and 270 because my angle is 210 degrees. Question 4 is asking what quadrant theta lies. That's pretty much just saying which quadrant is the terminal side. In this case would be this ray. Which quadrant does that lie in? And that's going to be quadrant 3. A review of quadrants gives us quadrant 1 right here, quadrant 2 right there. This is always going to be 3, and then this last one is 4. Now when it comes to reference angles, it's the amount of degrees that it would be closest to an x-axis. So in this case, my x-axis, that's 180 degrees right here, and to get from 210 back to 180, the difference of that is 30 degrees because I could take 210 degrees subtract that 180, and I'm left with 30 degrees. That's what I'm going to go with. I could have also done subtraction and taken 210 degrees away from this. Would have been a full 360, but that would have given us too much. Usually our reference angles are going to be either 30, 45, or 60. Questions 6, 7, and 8 require us to evaluate angles to come up with the value of that trig expression. So like I've been doing, I've been using 210 degrees. So I'm going to fill that in for all of these. Okay, and I could answer these questions in steps. The first thing I want to do is use my reference angle. And we know that, like we've done in my previous question, 210 minus 180 would give us 30. So that's going to be our reference angle. That means we refer back to the first quadrant of our unit circle, and we want to look at the coordinate point that is under 30 degrees. So the number one fraction I always tell people to remember is this very first one, the x value of 30 degrees. That's going to be square root of 3 over 2. The other fraction that matches up with that is 1/2. And then 45 always has a coordinate point of square root of 2 over 2, comma, square root of 2 over 2. Always, always, always. And then up here for 60, you just switch the x and the y for 30. That means the x value is 1/2. And the y value is square root of 3 over 2. So now we are going to use a reference angle of 30 degrees. We are trying to figure out sine. So we know that sine right here matches up with y. And we're using 30 degrees. So we take 30 degrees, look at our y coordinate. In this case it was 1/2. So then my fraction for sine of 210 degrees is going to be equal to 1/2. The last thing that we have to do is write whether this is going to be positive or negative. So back in our last questions, we were doing the angle of rotation. And 210 degrees, when we rotate it, it whoops, keeps going farther. It landed in this third quadrant, right? Well, we have to ask ourselves, is 210 degrees in the third quadrant give us a sign that is positive or negative? And remember, again, sine matches up with y. So basically, is y going to be positive or negative in this bottom quadrant? And it is always going to be negative. So I changed my 1/2 to be negative, and there's my final answer. So for cosine of 210, we go through the same steps. Again, we're going to use the reference angle of 30 degrees, but we need a new fraction. We do refer back to 30 degrees down here, but cosine is going to be matching up with our x value. So now I look at my x value for 30 degrees. That fraction is square root of 3 over 2. And again, I have to figure out, is that going to be positive or negative? In the third quadrant, all of my x values are going to be negative. So then I got to make this fraction a negative. Okay. And now tangent, this one tends to be the trickiest of all three. Because we're going to use this formula to figure it out. So now, according to the formula, we take sine and divide it by cosine. So my answer was negative 1/2. And I'm going to write this as a division like horizontally. So negative 1/2 divided by our cosine value is negative square root of 3 over 2. Now, if I write negative 1/2 divided by square root of 3 over 2, that's going to be the same thing as if I took, let me erase that, negative 1/2 divided it by a negative square root of 3 over 2, okay? But writing it horizontally helps me reduce it because I'm going to rewrite negative 1/2 like this, and what I have to do is change division to multiplication, and then I flip this fraction, the second one. So I'm left with 2 over the square root of 3. This, I think, in my opinion, is a lot easier to reduce than dealing with a fraction written vertically like up here. So 2 over 2 goes away, and then I'm left with a 1 over square root of 3. This was also negative, but technically a negative times a negative kind of cancels out. In a way, it becomes positive right here. So now I'm left with a 1 over square root of 3. I can never leave my fractions with a radical in the bottom, so what I have to do is multiply this bottom part by square root of 3 and the top part by the square root of 3. So 1 times the square root of 3 is the square root of 3. And then square root of 3 times square root of 3 is the square root of 9, which just equals 3. So I'll put that right there. That's going to be my final answer right here. So I'm going to say that this one is equal to, I'll put my answer right down here so it's easier to see. That's going to be a positive square root of 3 over 3 as my final answer.